All right. So, turns out I'm going to actually need this power supply to do the next lab because I need a 5-volt source and a adjustable voltage source. So I'm going to hurry up and finish building this thing. Well, at least the 5-volt portion, because I already have the adjustable portion that I need, unless there's a negative voltage that I need in this lab, but hopefully that's not the case. So let me just knock this sucker out. Five volts, 10 volts. Okay, it's done. Okay, so step 1 and 2. This is not the MOSFET that you would be using in class. This is a MPF 6659. So this is one of few MOSFETs that I actually have in the shack. So I'm going to do this experiment with this lab with this MOSFET. So these results will probably vary quite a bit compared to what you might be doing. So I have here some specs of this MOSFET. So let's just get started. Just gotta break these leads apart a little bit. Okay, so this is the diagram we're going to be using, and in the lab we're actually going to be using, not sure if you can see that or not, anyway, in the lab for power supply 1 I believe we're going to be using 5 volts. So GS, gate and source is going to be 5 volts. Okay, and this is going to be our variable power supply, which we already made one of these, so this is going to be perfect to use during this lab. And gate is pin 2. Drain is pin 3. And source is pin 1. Let me make sure this is unplugged. I was just testing this to make sure it was in fact working. So let's move this out of the way for now. So we have here our ground, which is going to be source, which is also going to be pin 1. And then we have our gate, which is pin 2, and that's going to be 5 volts, which is this one. Then we have our drain, and drain's pin 3, and that's going to be our adjustable power supply. That's this one right here, but I'm just going to set this up to monitor current because I'm getting tired of hurting my meter. In case you couldn't tell, this one's the one I use outside. This one I use inside. So this one's a lot cleaner. Okay, I'm actually going to measure this voltage before I put it on to make sure it's close to 0. I don't want to be putting full voltage through when I'm not supposed to. All right, 1.2 volts, which well, we're supposed to be putting 0 to 2 volts in at the beginning, but beggars can't be choosers. We're just going to have to start from there and work our way up. So let's go ahead and connect. Yeah, I probably should have used this meter to do the other labs because it's more precise, but can't really redo things. Alright. Let's start with the first set of measurements here. Okay. So our first voltage, you know what, let me get some alligator clips for this one. Okay. Alright. Now hopefully I can crank through this pretty quick. I'm just going to take the first measurement and then hopefully just fast forward the rest because it's going to be quite repetitive. Oh man, actually, let's see what our 5 volt, let's just get this out of here. Okay. Okay. That being 5 volts, what's the voltage and current? Okay, and then we got Alright, we got 1.047 volts and 0.137 amps. So 0 to 2 in, alright. Okay, so that was actually the most our power supply could actually put out. That's pretty hot. Yeah, these all our components are pretty nice and toasty. So that's as much as it could really do. Couldn't crank it more than that. So that's too bad. So that's step 1 and 2. Okay, so for this next part, we're going to do the exact same thing, but instead of just a 5 volt on power supply 1, we're going to have a 3.5 volt and a 1 volt for that power supply, and then we're just going to make the current measurements and then the voltage measurements of the power supply. So anyway, it's going to be kind of a pain in the butt. So let's see. I had to make another voltage regulator for, well, because now we have 2 different voltages, well, kind of 3 different voltages, but I'm probably going to toggle between 3.5 and 1 volts. Obviously, those are the ones that have a little wiggle room since they don't have you record those numbers. But what I am going to change is this is going to be 1.274 volts, and that's just because that's the lowest this power supply right here will go. So it's going to have to be what it is. Anywho, so let's bring back the current. I think I'm going to have to get another multimeter on this, unfortunately. Alright. I guess that's just going to have to go there. .271 volts, and then .007 amps. Much better. All right. Oh boy, that was nice. Okay, so this next step here is actually going to be a little interesting. We're going to use this MOSFET to act as a resistor. Well, measure the resistance. So we're going to remove power supply 2 and replace it with a multimeter, and we're going to measure the resistance across it as we vary the voltage on the gate. So let's go about doing that. So all right, from 2 volts to 5 volts. Okay, so that should actually be fairly straightforward. So we need, okay, that's correct. 1 ground, 3. So between 3 and ground. Okay. Then we're going to remove that. And we're going to put, let's see, we're not measuring, we're just measuring voltage. We're not measuring current. That actually goes over here. And then this one comes over here to the gate. Okay. And let's change these leads up. Okay, so from 2 to 5 volts, 200 millivolt increments. So that's okay. All right. So expect between 200 and 2 kilo ohms, and we're getting 10 ohms, but this is a different MOSFET, so that's fine. So let's see. Okay. All right. Okay, so according to the lab, we want to pick a resistor that's about 10 times our lowest resistance value. And for my device, I was getting negative resistance because current was flowing the opposite direction and passing over the voltage that goes through for the digital multimeter to detect current. So I'm just gonna look at this value right here, these three values, and I say, well, let's just say it's 0 ohms, because back here you're getting negative resistance, and that's a resistor that creates current, which this this resistor really was creating current. That's why this was negative, which real resistors don't do that. If they did, we wouldn't have any energy problems. We just put a negative resistor in a circuit and the thing would run forever. Anyway, so I'm just saying it's 0 ohms or 0.1 ohms. So I'm just going to put a 1 ohm resistor in and use that in the voltage divider and see how that turns out. So let's see. All right, so we have voltage going across the gate source. Let me go back and look at the data sheet. Not data sheet, but let's look at this for a second. So this is pin 2. And this is, well, should be pin 3. Let's see. Three and 1. Okay. So we got that down. Let's see. We have a 1.3 volt source, which we're really just going to go as low as we can. And we're going to be using this second voltage source to adjust this VGS. So let's see, that's going to be going into pin 2. let's see. Actually, it's probably better if we just start over and try not to complicate things. So we have 5 volts, we're not going to use that. Then over here we have a adjustable voltage, and that is, we're just going to say that is going to be this one, the VGS. So that's going to be in terminal 2. There we go. Done. Now we have our positive voltage source, and we're going to have it go from here, and we're going to bring that over to the pin 3, and that pin 3 is also going to be our output voltage. Okay, so we're going to set our output voltage ground it, and put output voltage there. Okay. Our second voltage measurement is going to be right over here on the gate. And just to be safe, I'm going to unplug this, move it up here, and I'm going to calibrate everything before I power it. Okay, so both voltages are right where we need them, very low. So we can put this where it belongs. Okay, see if we can move this without disturbing anything. Everything looks good. Now, pin 2 is where we're going to be adjusting our voltage. Pin 2, so it's this potentiometer that we're going to be adjusting. So VGS is, oh, if only I didn't tangle these cables. Okay, so this should be VGS. And then this should be the output voltage. Okay, and now we're going to increase by roughly 300 millivolts. Okay, done with that part.